Hi, welcome to the Olympiad geometry. Let's continue our study on radical axis. Before we start, if you think this video is helpful, please click the like button, make a comment or share it, or subscribe the channel. Thank you. So here I put two problems here. Let's just look at the first one and then the second one. They're very like each other, I would say. The first one, we want to prove diagonals ADBECF of a circumcircle tangential hexagon are concurrent. It is seen that for circle, let's first find a circumcircle tangential hexagon here, which we can set it as A, B, C, D, E, so we need another F. This is F. Right, so this is A. A, B, C, D, E, F. And we want to prove that ADBECF are concurrent. This is a very interesting problem because I'm not sure if there's any other way to do the proof. I didn't think of, but because this problem, when I see this problem, it's under the chapter of radical axis. So the easiest way to think of it is that we can make BE, AD, and CF to be three radical axes for three circles, right? For three intersection circles. These are the three radical axes. And we directly prove that they are concurrent. So we just need to prove ADBECF can be three radical axes of three circles, right? Now the problem is that how to construct these circles. Let's just take ABED for a second. Let's see if we have a circle here. We know the tangents line are in arbitrary angle, right? So we just do arbitrary drawing here. One observation is that because this is a tangent point, this is a tangent point, and we already know that they are tangent to the circle, so the distance from the center to these lines are equal, right? Which means if I just find the equal space here and another equal space point here, right? So say it's let's say it's x, y, right? And this is O, this is AB. If AX equals to BY, right? We can simply draw the parallel line of OB and parallel line of OA through Y and X respectively, and call the intersection point O prime, and we connect OO prime. We know that eventually the angle bisector of this BY line and AX line, right? And we know that O prime X equals to O prime Y, and AX equals to BY. That is critical. And based on this knowledge, we can now construct the circle. Why this is critical? Because by equals to ax. So I want to use AD. Think about that. I want to use AD as radical axis. That means if I have a circle, right? If I have two circles, so AD is a radical axis. If I have two circles here, oh, my bad. AD may not be just on the intersection point, right? A is here, for example, D is here. AD are on the radical axis. So I have two circles here. Then the distance, so from A we can do tangent to circle O1 and circle O2. The tangent AP, AQ are equal, right? So based on this by equals to ax, we can do what? Now we just define the line here, the point, tangent point here, A, B, C, D, E, F, right? So G, H, I, J, K, L. Now we do this. We start from this tangent point. We find the equal distance here. We call it G prime. We call it G prime, right? And if we look at the AB line, so 1, 2, 1, 2, right? So AB line and the EF line. They are on this way, so we from J find another point we call J prime. We already know that AG and EJ are tangent to this circle, right? So we can find another circle that tangent at G prime and J prime, right? That's just on the angle bisector of the angle that formed by the AG and EJ, right? O is here. O must O is here. O must be on the angle bisector of the angle, and we can find another 2 point because see here. This is 90 degrees, this is 90 degrees, so we must be able to find another point that to be 90 degree of here, 90 degree of here, right? Then we can draw that circle. That circle is tangent to the AB line and the ED line on the point G prime and J prime, right? Similarly, we can use, let's set this distance G prime equals to, for example, D. So we can find the same distance from H, right, to here. We call it H prime. And for this one, we can start from K. We find another point, K prime, right? So H prime and K prime. Then we know we can draw another circle. That circle is tangent with BC at H prime and tangent with EF at K prime, right? Because this can be, let's draw this. This would be easier to look at, right? So we can find the circle around here, right? That's circle O1, and this is circle O2. And similarly, we can find another point. So remember that GG prime equals to D and HH prime equals to JJ prime. HH prime equals to D equals to KK prime, right? And LL prime equals to II prime equals to D. I'll do that. L prime would be here, and I prime would be here, right? So this is perpendicular. This is perpendicular. Then we know that we can find here. If we say here, that's O3, right? So for O1, the radius is O1G prime, and for O2, the radius is O2H prime. For O3, the radius is O3I prime. We can find these three circles, right? And for the circle, look at here. We know that BG equals to BH, right? And we already set GG prime equals to HH prime. So we know that BG prime equals to BH prime, right? BG prime equals to BG minus GG prime equals to BH minus HH prime equals to BH prime, right? So for the circle O1, the power of B to circle O1 is equal to BG prime square, right? Because BG is a tangent. BG is a tangent to circle O1, and for the circle O2, the power of B to the circle O2 is BH prime, right? Because BH is a tangent of circle O2. So BH prime square. So we already know that BG prime equals to BH prime. So BG prime square equals to BH prime square. Then we know that B is on radical axis of O1 and circle O1 and circle O2, right? Similarly, for here we have circle O1 and circle O1 and circle O2 here, right? If we look at the point E, right? Because EJ equals to EK and JJ prime equals to KK prime. So EJ prime equals to EK prime, right? And the power of E to the circle O1 is EJ prime, right? Because EJ is a tangent of circle O1, and EJ prime square would be the power of E to circle O1, and the power of E to circle O2 would be EK prime square, right? Because EK prime is a tangent of circle O2. So, and it equals to EK prime square, which means that E is on the radical axis of circle O1 and circle O2, right? That means BE is radical axis of circle O1 and circle O2, right? Similarly, we can prove that AD, see here, AD, AG prime is to circle O1, right? And it would be equals to AL prime, that is circle O3. So AD would be similarly DJ and DI. dg and dj and dj equals to di. So di prime and dj prime would be the di prime and dj prime would be the tangent from D to circle O1 and circle O3, right? So AD is radical axis of circle O1 and circle O3. And for CF, CH prime is a tangent of circle O2, and Ci prime is a tangent of circle O3, right? And we know that CH prime equals to Ci prime. So the power from C to circle O2 and circle O3 are equal, which means that C is on the radical axis of circle O2 and circle O3. Similarly, for F point, we know that Fk prime is a tangent of Fk prime is a tangent of circle O2, and Fl prime is a tangent of circle O3, right? Fl equals to Fk and Kk prime equals to Ll prime, so Fl prime equals to Fk prime, right? So that Fl square equals to Fk square, which means the power of F to circle O2 equals to circle O3. So CF is radical axis of circle O2 and circle O3. Okay, now we know that BEAD, CF are radical axis of three circles, and they must be concurrent, right? We proved that in the radical axis properties. That's for the first problem. And second problem is even more interesting. I call it one sentence problem. It's like you can just explain the solution in one sentence. But let's see. DD prime are 2 points on the edge DD prime are 2 points on the edge BC of triangle ABC. EE prime are 2. Let me just draw it. Okay, so we have a triangle here, A, B, C. DD prime are 2 points on the edge BC, right? So DD prime. And EE prime are points on edge CA, EE prime. FF prime are 2 points on AB. And we know that DD prime, EE prime are cyclic. EE prime, FF prime are cyclic. FF prime, this is F. FF prime and DD prime are cyclic. Prove DD prime, EE prime, FF prime are on same circle. So think about that. We have two circles. One circle is defined by DD prime, EE prime, and another circle is defined by FF prime, EE prime, which means these two circles intersect on EE prime, right? That means AC is a radical axis of the circle defined by this one and this one. Similarly, AB would be radical axis defined by EE prime, FF prime, and DD prime, FF prime, right? And also BC would be the radical axis defined by FF prime, DD prime, EE prime, DD prime, right? That means we have three circles intersect each other, and the radical of two, right? Three radicals of the circles form a triangle, which is impossible, which means that these points must be on the same circle, right? DD prime, the circle DD prime FF prime cannot be different to the circle EE prime FF prime, right? Okay, that's the second problem. So for today, the two problems are not like common problems that we need to analyze analyze a geometry figure a lot. So this problem is more about thinking, right? We need to think hard to find a way to construct the proper circles and find the radical axis that we can use to prove the concurrent or prove other things, right? Like these 6 points are on the same circle. So I think these problems are very interesting because it's just not like what we used to see. It requires more about the construction rather than analysis. It's like a reverse way of thinking things. So I hope you like this video. See you in next one. Thank you.